What if a soccer ball had to be plugged in before kickoff? At the 2026 World Cup, that's not a hypothetical. Every official match ball now carries a tiny computer sealed inside it, logging its own movement 500 times a second. If that computer runs out of power mid-game, the data feed goes dark, and so does part of the officiating system. Today, we're heading inside the factory where this ball gets built, panel by panel, sensor and all, to find out how a piece of sporting equipment became one of the most sophisticated pieces of wearable tech on the planet. Adidas has supplied the official World Cup match ball since 1970, when the black and white Telstar gave the tournament its first iconic look. For decades, that meant 32 stitched panels, the classic hexagon and pentagon pattern everyone pictures when they think soccer ball. That started changing in 2006, as Adidas pushed toward fewer panels and seamless, thermally bonded shells. By 2018, the Telstar 18 carried a chip too, but just a passive NFC tag for fans to scan with their phones. The real leap came in 2022, when the Al Rihla became the first World Cup ball with a center-mounted motion sensor feeding live data straight to referees. Now meet the Trionda, the official ball of the 2026 World Cup, hosted jointly by Canada, Mexico, and the United States for the first time in history. The name fuses tri for three host nations with the Spanish word onda, meaning wave. It took Adidas and FIFA 3.5 years of design, blind testing, and weather trials to finalize it. The journey starts in Sialkot, Pakistan, a city that produces roughly 70% of the world's soccer balls, despite Pakistan never having played in a World Cup itself. Inside the Forward Sports Factory, massive sheets of polyurethane, backed with reinforcing cloth layers, roll off industrial presses. A die-cutting machine, essentially a giant precision cookie cutter, stamps out just 4 panel shapes per ball, instead of the 12 used on the previous World Cup ball or the 32 of decades past. Fewer panels mean fewer seams, and fewer seams mean a more predictable flight path through the air. Each panel's surface gets a textured treatment afterward. Tiny debossed patterns, visible only up close, that improve grip in wet conditions and help control airflow as the ball spins. Engineers spent years in wind tunnels chasing this exact texture after earlier low-panel balls, like the infamous 2010 World Cup ball, earned a reputation for unpredictable knuckling flight at high speed. Did you know? The 2010 World Cup ball's flight problems came down to something called a drag crisis, a point where airflow suddenly shifts from smooth to turbulent, making the ball decelerate erratically in midair. Before the panels are sealed into a sphere, they're flat, and flat is exactly when they get printed. Specialized presses apply the Trionda's swirling red, green, and blue artwork directly onto each panel, representing Canada, Mexico, and the United States. Hidden within the pattern are 3 small icons: a maple leaf, an eagle, and a star, one for each host nation. Gold detailing traces the edges, a nod to the World Cup trophy itself. Printing happens on flat material because curved surface printing is far less precise. Any curve introduces stretch and distortion that would warp a logo or blur fine line work. Technicians inspect every printed panel under bright lighting, checking for color bleed, misalignment, or faint printing before it ever reaches the assembly line. A single flawed panel gets pulled and scrapped immediately, because once panels are bonded together, there's no fixing a printing error after the fact. This is where the Trionda stops being just a ball. One of the 4 panels gets a special internal pocket built into its structure, a precisely shaped compartment that will hold the ball's brain. A 500 Hz inertial measurement unit, or IMU. Unlike the 2022 ball, which mounted its sensor dead center using a suspension harness, engineers moved this one off to the side, embedded directly into a panel layer. That creates a balance problem, so workers add small counterweights into each of the other 3 panels, canceling out the sensor's mass so the ball still flies true. Did you know? The sensor captures the ball's motion 500 times every single second, fast enough to record the exact millisecond contact is made on a handball or an offside pass. With panels printed and the sensor pocket built, it's time to seal the ball shut. And that means heat, not thread. Workers position all 4 panels and the inflatable bladder inside a heated mold, then apply intense pressure and temperature, fusing the polyurethane edges into a single, seamless shell. There's no needle, no thread, no stitched seam anywhere on the surface. This thermal bonding press has to be calibrated to the degree. Even a slight temperature miscalculation can warp the panel or weaken the bond. The payoff is a ball that barely absorbs water, holds its shape under repeated impact, and slices through the air with none of the drag that stitched seams used to create. Once bonded, the ball gets inflated to match pressure and rolls straight into the gauntlet. FIFA's 7-test certification process. Inspectors check weight, which must land between 410 and 450 grams, and circumference, which has to fall between 68 and 70 centimeters, measured at thousands of points around the surface to confirm true roundness. A rebound machine drops the ball 10 times from 2 meters onto a steel plate, checking that it bounces the exact same height every time. Separate tests measure water absorption and confirm the ball won't lose more than a small percentage of its air pressure over 72 hours. Only after passing every single test does a ball earn the FIFA Quality Pro mark, the only certification allowed for actual World Cup matches. Did you know? FIFA requires at least 10 sample balls from the same production batch to pass testing, not just one perfect prototype, to guarantee every match ball performs identically. Everyone assumes the trophy lifted at the end of every World Cup is solid gold, a heavy, glowing brick of pure wealth. But here's the catch. If that trophy really were solid 18-karat gold all the way through, it would weigh somewhere between 150 and 180 pounds. No player, no matter how strong, could hoist that over their head in celebration. So why does this object look, shine, and gleam exactly like solid gold, yet weighs barely 13 pounds? The answer is sitting inside a small, pink-walled factory on the outskirts of Milan, where a tiny team of Italian craftsmen has quietly rebuilt this exact trophy by hand, every 4 years, since 1974. The World Cup hasn't always used this trophy. The original, the Jules Rimet Cup, was made of silver gilt and nearly lost forever twice. Stolen once in 1966, right before the tournament kicked off in England, and famously found a week later by a dog named Pickles, sniffing through a hedge on a quiet London street. The second theft, in Brazil in 1983, was never solved, and the trophy is widely believed to have been melted down. After Brazil's third championship in 1970, FIFA retired that trophy for good and held a design competition. Italian sculptor Silvio Gazzaniga's concept beat out 53 entries from 7 countries, depicting 2 athletes lifting the globe in a single, continuous spiral of motion. His design became the trophy we know today, introduced at the 1974 World Cup, and it's been built by the same family-run company, GDE Bertoni, ever since. Every trophy GDE Bertoni produces starts the same way the originals were made thousands of years ago, with lost wax casting. This is where the trophy actually starts to look like a trophy. Die grinders, small, high-speed rotary tools, strip away the excess metal left over from casting, roughing out the basic silhouette of the 2 athletes and the globe. Then, the real artistry begins. Veteran craftsmen, some with decades at the company, pick up hand chisels and small hammers and refine every muscle line, every fold, every curve of the figures by tapping metal millimeter by millimeter. No machine touches this stage. It can take days of careful, repetitive striking to bring out the dynamic tension Gazzaniga originally sculpted in wax. The sense of two athletes caught at the exact instant of victory. A single slip of the chisel at this stage can ruin hours of previous work, so craftsmen work slowly, checking their progress constantly against reference photos of the original. Did you know? G.D.E. Bertoni's chiseling specialists trained for years before being trusted to refine an actual World Cup trophy. Some have worked exclusively in this department for over 2 decades. Now the trophy gets its glow. Workers submerge it in a galvanic plating bath, running an electric current through a gold solution that bonds a microscopically thin layer of real gold onto the brass surface underneath. This isn't a single quick dip. The trophy passes through the plating bath multiple times to build up an even, durable gold finish that can withstand being passed hand to hand through celebrations, photo shoots, and tours for years afterward. At the end of the gilding bath, the trophy is carefully washed in distilled water. The trophy's signature touch goes on. 2 malachite stone bands, a deep green mineral, mounted around its base, framing the engraved inscription FIFA World Cup in striking contrast against the gold. Finally, a clear protective coating called Zapon varnish gets applied across the entire surface, locking in the shine and guarding the gold layer against tarnishing or scratches. The trophy's journey doesn't end when it leaves the factory. It ends on the pitch, moments after the final whistle blows. A removable plate on the underside of the base sits blank until the very last second, waiting for one name. As soon as the championship match concludes, that plate is engraved on the spot with the winning year and country, then attached to the trophy just before it's handed to the captain in front of a global television audience. After the celebrations end, the original gold trophy goes back to FIFA's museum in Zurich, while the brass and gold replica stays permanently with the winning federation, a country's name etched into the same design that's honored every champion since 1974. Why does building a single stadium screen take up to 2 years when the television in your living room ships to your door in a matter of days? At World Cup 2026 venues across the US, Canada, and Mexico, the massive LED video boards firing up the crowd before kickoff, replaying goals in an instant and turning 60, 70, even 80,000 strangers into one roaring voice aren't just oversized TVs. They're some of the most complex display systems ever engineered, built to survive wind, rain, blazing sun, and a decade of non-stop use without a single dead pixel. Today, we're stepping inside the factory floor where these giant cheering screens come to life. The company behind many of the screens lighting up American stadiums this World Cup is Daktronics, founded in 1968 in Brookings, South Dakota. What began making simple scoreboards has grown into the world's leading large-format LED display manufacturer, with installations at 154 professional sports teams and over 1,300 college programs. At Gillette Stadium outside Boston, one of the venues hosting 2026 World Cup matches, Daktronics has built a relationship with the team since the stadium opened in 2002. And today, the venue holds 47 separate Daktronics displays, totaling more than 48,500 square feet of LED canvas. Across the tournament's 16 host stadiums, these screens do more than show the score. They drive crowd energy directly, syncing replays, fan cams, and hype graphics to the exact rhythm of the match. Before a single LED gets soldered, engineers spend weeks designing the screen specifically for its stadium. CAD drawings and electrical schematics map out exact dimensions, mounting points, and structural loads because no two venues are identical. One of the biggest decisions is pixel pitch, the precise distance between individual LED clusters. A screen meant to be viewed from the cheap seats, hundreds of feet away, can use wider pixel spacing without losing clarity. But a display mounted close to premium seating needs LEDs packed much tighter, since viewers sitting nearby would otherwise see individual dots instead of a smooth image. Why does this matter so much? Because getting pixel pitch wrong means either wasting money on resolution nobody can perceive, or building a screen that looks blurry and pixelated to thousands of fans paying full price for their seats. Did you know? A single large stadium video board can contain more than 30 million individual LED pixels, more than 10 times the pixel count of a typical home television. Inside the factory, bare circuit boards roll beneath high-speed pick-and-place machines, which position thousands of tiny red, green, and blue LED chips onto each board with roughly 98.5% placement accuracy. These machines work far faster and more precisely than any human hand could, placing components at a rate of dozens per second while maintaining microscopic alignment tolerances. Each board will eventually become one module, a building block tile that gets combined with thousands of identical modules to form the finished screen. Why use 3 separate colored chips per pixel instead of 1? Because red, green, and blue light, blended in different intensities through additive color mixing, can reproduce more than 16 million distinct colors, everything from the deep green of the pitch to the bright gold of a replay graphic. Once the LED chips are placed, the boards pass through reflow ovens reaching temperatures between 245 and 260 degrees Celsius, hot enough to melt the solder paste beneath each component and fuse it permanently to the circuit board. The heating happens gradually, ramping up just a few degrees per second, because a sudden temperature spike could crack a chip or warp the board entirely. As the boards cool, the molten solder hardens into a durable metallic bond capable of withstanding years of vibration, temperature swings, and electrical current without failing. Workers then run the boards through automated optical inspection, where high-resolution cameras and AI-driven software scan every single solder joint for cracks, gaps, or misalignment, catching microscopic defects invisible to the human eye before a board ever reaches the next stage. A stadium screen has to survive what no indoor television ever will: driving rain during a tense second half, blazing summer heat radiating off concrete, and freezing nights in early rounds of the tournament. To handle that, workers apply a multi-layered protection process. Silicone is poured into and around each LED cluster to seal out moisture, and a conformal coating adds an extra layer of chemical resistance across exposed circuitry. This process is what earns outdoor displays an IP65 weatherproof rating, meaning the module is fully sealed against dust and resistant to water jets. The result is a board engineered to keep functioning reliably across a temperature range running from well below freezing to well over 100 degrees Fahrenheit, with an expected operating lifespan well beyond 100,000 hours of use. Did you know? IP65 rated outdoor displays are designed to keep working through more than a decade of stadium weather, sun, rain, snow, and everything in between, without needing to be replaced. In the final stage, calibrated modules get mounted into aviation-grade aluminum cabinet frames engineered to withstand wind loads up to 50 miles per hour. A real concern for screens mounted dozens of feet in the air above an open stadium bowl. Power supplies, cooling fans, and control cards get wired into each cabinet before it undergoes a 72-hour burn-in test, running continuously to surface any early hardware failures before installation. Some cabinets also go through thermal cycling, swinging between extreme cold and extreme heat to confirm every solder joint and component can handle real-world conditions. Only after passing every test does the cabinet ship out to its stadium, where crews assemble dozens of these modular sections into the finished screen fans see towering over the field. Why does all of this take up to 2 years from first sketch to final installation? Because a television in your living room only has to survive your couch. A World Cup stadium screen has to survive a decade of crowds, weather, and roaring celebrations flawlessly every single time. So what does it mean when a soccer ball has a computer inside, a trophy isn't solid gold, and a stadium screen takes 2 years to build? It means this World Cup isn't just about players on a pitch. It's a showcase of human ingenuity working behind the scenes to deliver every perfect kick, every soaring celebration, every Jumbotron replay. From Pakistan to Italy to South Dakota, thousands of people are making sure the beautiful game stays flawless. Next time you watch a match, look closer. That ball flying past the goal? That trophy glinting in the lights? That screen erupting with joy? They're all machines of memory. And if you like this look behind the curtain, like, subscribe, and hit the bell. We'll bring you more hidden worlds.